Okay, in example 2, in our PowerPoint, it says there that the acceleration of a motorcycle is given by this equation. A as a function of time, we have at minus bt squared, where the value of A is 1.50 meters per s cube. Okay? Take note that the unit here has to be s cube so that this over s cube here divided by times the second here, you'll have meter per second squared as a unit. And then B is this value. So if we plug in the values of A and B, our general equation for A at any time t is 1.50 t minus 0.120 t squared. Okay. And another information is given by this sentence. The motorcycle is at rest at the origin at time t equals 0. So, motorcycle is at rest. Immediately, you sketch that information in your paper, no? Kung nagsosolve kayo. So, the velocity of the motorcycle, it is at rest when time is 0. So, velocity when time is 0 is 0. We can also write this as velocity at time 0 as Vox. And it is found at the origin when time is 0. So, its position when time is 0 is also 0. We can also write this as x position when time is 0. So, take note of that. Okay. Requirement A, you have to find the position as a function of time and velocity as a function of time. Take note that the question is asking only of the general equation of general expression of x as a function of time. There's no specific time given yet. So in your final answer here, it will just be a generic equation with variables t. Okay, so let's recall. I hope you've read your book and your lecture notes, no? So if you're given the acceleration as a function of time and you are to determine this, then we will be working backwards. So if in the previous examples, you were given x as a function of time, tapos nag-differentiate tayo, we got the derivative, then yung opposite ng differentiation is of course integration. Tama ba? So we will just get the integral of this. So, how do we do that? Before we get this one, unahin na muna natin to, because the integral of this is equal to that. So, how do we do that? Let's start with the main definition. We say that if we get the integral of a as a function of time, okay, dt, and that would be from time t1 to time t2. In this case, our t1 is 0. So, let's just have our lower limit as 0. And final time is later time t. Okay, so the integral of this would be your velocity function, no? Plus, to complete it, we have the velocity as time is equal to 0. And this will give us velocity at any later time t. So, take note. Pag may subscript na 0, meaning that's the velocity value when time is 0. In this case, so take note, this is a general definition of velocity, no? The integral. Kasi if you get the derivative of v with respect to time, ang makukuha mo, so pag ililipat mo ito sa kabila, d dt of vx, ang makukuha mo, ax of t. Tama ba? Okay. So, let's continue. In this case, sabi, it's at rest when time is 0. So, tanggalin na natin to kasi 0 na yan. And then next, we will just plug in the expression for a as a function of time. So, we get the integral from 0 to t. Ax of t is ito. So, ilalagay natin siya sa parenthesis. 1.5t minus 0.120 t squared. And then, of course, our integral variable is time, of course. Tama ba? Okay? So, power rule lang. If you recall, okay, di ba opposite ng ng differentiation si integration. So, in terms of, recall muna tayo sa math ha. Diba nung na kumuha tayo ng derivative, sabi natin, if we want to get the time derivative of, let's say, t to exponent n, diba, nag-ano tayo, n times variable t, tapos n minus 1. Tama ba? That's to get the derivative of this variable, no? In terms of t, kasi time ang, time derivative. So, kung nag-minus 1 tayo sa differentiation at saka nag-multiply, edi sa integration, magpa-plus 1 tayo, tapos magdi-divide. Tama ba? So, in other words, if we get the integral of, let's say, t to any exponent, okay, dt, then we say that it's t n plus 1 over n plus 1. So, ito yung gagamitin natin sa bawat term dito. Okay? Of course, I know that you already know this, but there's no harm in reviewing. Tama ba? So, gamitin natin tong power rule na ito in simplifying this. And please help me ha. Sometimes kasi iba yung sinasabi ko sa sinusulat ko tsaka sa iniisip ko. So, later, pag may nakita kayong mga iba sa sinabi ko, iba yung sinulat ko, please comment on it para maklaro natin sa online conference natin. So, in this way, in this manner, we have here, so we have 1.5, and then you have the invisible 1 there, plus 1, and then 1 plus 1 here is equal to 2 already, minus ito, dyan pa rin siya, and then we have 2 plus 1, ito siya, 3 na dito sa baba. So, we'll have here 0.75 t squared minus 0.04 t cubed. Okay, and then our unit here, of course, is meter per second. So, this is now our velocity at any time t. This is now velocity as a function of time. So, we can easily determine the value of v at any time values that we like here. Tama ba? Okay, let's continue. So, since we now have our v as a function of time, then if we get the integral of this plus x position initial, then that will also give us x as a function of time. Okay, let's continue. So, I'd say that by definition, if we get the integral of v as a function of time, dt, from 0 to t, plus the initial position, this is by definition ha, this will give you position at any later time t. Okay, and then we just put in the expression that we have here. So, we integrate from 0 to t. It's 0.75 t squared minus 0.04 t cubed dt. And then, using this sa bawat term natin dito, we'll have 0.75 t 2 plus 1 over 3 minus 0.04 3 plus 1 over 4. Tama ba? Over 4. So that x here at any time t, okay, by the way, ito is 0. So, kasi nasa origin daw siya pag start ng timer. So, this is divide by 3, you have 0.25 t cubed minus this is 0.01 t to the fourth. Ito silang lahat, ang unit nito, meter. Kasi this is position at any time value that we want. Okay? So, that's our answer. These are our answers for part A. Okay? Please review and tell me if something is wrong. Okay? I'll see you later.